Hello, everyone. In this video, we will be exploring a technique called data binning or bucketing. Now, some practitioners in the field call it a data pre-processing technique, while others think of it as a feature engineering step. Feature engineering is any step that brings out or enhances the hidden information, trend, or signal in the data, thus enhancing its quality and making the final machine learning model better at making predictions. Like before, whichever way you go, the most important thing is to understand what it is, why it is helpful, and how can it be done. So let's start by understanding what data binning is. Data binning is a process that involves converting continuous data points into categorical intervals. It makes the raw data more useful by reducing the noise in the data, handling outliers effectively, and in general, making the model more accurate and precise if done correctly. For example, in our electricity demand forecasting app, using the London temperature example, we may say that 26, 27, and 28 degrees feel equally warm to me, and we will switch on the fan as soon as the temperature goes beyond 25 degrees. Or you may say that it doesn't matter whether it is 31 degrees or 32 or 33, I will switch on the air conditioner as soon as the temperature goes up above 30 degrees. In cases like these, it is not the actual temperature value, but a small temperature value range that decides the electricity demand. This hidden information can then be extracted from the data by making small bins or buckets or categories. And so we can replace all temperature values between 0 and 5 degrees with, let's say, T1, values between 5 and 10 with T2, and so on. We will see in detail how to work with categorical values in machine learning in the next video. For now, let's stick with binning. Now, how do we perform data binning? There are several methods, but we'll focus on two primary strategies. The first strategy uses equally spaced boundaries. It divides the range of data into intervals of the same size, like we just discussed. 0 to 5 degrees is one category, 5 to 10 degrees is another category, and so on. It's a simple and straightforward strategy, but might not represent the underlying distribution of data accurately. For example, what if one year, London is too hot and there are almost no values in the 0 to 5 category, or maybe it's too cold and there are no values in the 30 to 35 bucket? In such a case, we can use a second method that creates bins using quartile boundaries. This means that each bin will contain an equal number of data points. And so if you create 5 bins, each will contain 20% of the total values and so on. While slightly more complex, this strategy can be particularly useful for handling skewed data and for ensuring that each bin is statistically meaningful. And that is all for data binning. In the next video, we will see how to implement these strategies on real-world data. See you there.